In this video, we're going to be talking about standard form of a line, which is our third form to go along with slope-intercept form and point-slope form. So each of the forms of the line have their own advantages, which is why there are several that we learn. So to get started and to see the advantage for yourself, let's go ahead and do this warm-up. It says graph the equation by putting it in slope-intercept form. So again, the advantage of slope-intercept form, which of course is, let me get my pen ready here, which is y equals mx plus b. We can look at the equation and we just know what the slope is and we know what the y-intercept, making it simple to graph. The problem on this one is it's not in slope-intercept form, so we have a little bit of work to do first. So to get in slope-intercept form, we want it to say y equals. So I want to remove the 2x from that side. So I subtract it, giving me negative 2x plus 8. And then I have to divide by 4. And we have to make sure when we divide, we're dividing the entire side. In other words, every term gets divided by 4. And I reduce that and I get negative 1/2 x plus 2. Now that I'm in slope-intercept form, now I can go ahead and graph it. Let me turn this on temporarily. And so my y-intercept is 2. My slope is negative, so I'm going down 1 over 2, or up 1 over 2. And I get my line. So certainly not complicated in any way, very easy to do. But there is another approach to graphing this equation. So let me turn that off for a moment. And let's go ahead and look at warm-up number 2. So on warm-up number 2, we want to use the same equation. So let me write it over here. 2x plus 4y equals 8. And what I've asked you to do is to complete this very small table, very specific table of values, by plugging in 0 for x. Now, I'm going to repeat this table here without the question marks. So if x is 0, I'm going to plug 0 in, and the math becomes very simple because, see if my clicker is working, it is not. When I plug in 0 for x, then 2 times 0 is 0, and the problem just becomes 4y equals 8. And then I can hopefully just do in my head and divide by 4, and I see that y equals 2. So it's very easy to plug in 0 and do the math in this case. So I plug in 0, and this whole 2x term just disappears, and I'm left with 4y equals 8. So now what I'm going to do is I'm going to repeat that same process, except this time I'm going to let the y value equal 0. So I'm going to plug in 0 for y, and then, in this case, now I've got 4 times 0, but that's just 0. So that leaves me with 2x equals 8. And I can divide by 2 in my head, and I get 4. So I can quickly, and much even quicker than I did it there, because I wouldn't, I don't have to talk through it. I can get those 2 points, in under 4 or 5 seconds. So now I know that to graph the equation of this line, and we'll just go ahead and back over to my other one and turn my lines back on. I'm going to graph the point 0, 2. Well, the point 0, 2 is just this point right here. And I'm going to graph the point 4, 0, 1, 2, 3, 4. That's this point right there. And then I can connect those, and I've got my line. So that is something that I can do like almost instantly. Like there's very little, at least, thinking going on. The only time it's going to take is just the time to actually physically write it down. So very, very simple to do. So that is, again, just to review, we plugged in 0 for x, and that found us a y value of 2. Notice that is a point, 0, 2. We have a name for that. That's the y-intercept. And then I found the point 4, 0. Well, we have a name for that we haven't really talked about yet, but that is the x-intercept. So this method is actually about finding the 2 intercepts and then connecting the line between them. All right, we're going to spend a little more time with that today, but let's get some formal definitions going. All right, so today we're learning about standard form of a linear equation. The standard form of a linear equation is ax plus by equals c, where a, b, and c are just integers. They're just whatever integers they happen to be, as long as a and b are not both 0. Okay, they can't both be 0. One of them can be 0, but not both. All right, and we'll see what that looks like in just a moment. And then these definitions, again, you should probably be able to figure out, or you already know. We've already talked about the y-intercept extensively. The point where the line crosses the y-axis, that's called the y-intercept. We can find that point by plugging in 0 for x. And my question is, why does that find the y-intercept? Why does plugging in 0 for x find the y-intercept? And I hope the answer, if you just bother to take a second to think about it, makes perfect sense. If this is my x-axis and this is my y-axis, and I'm going to graph a point, so plugging in 0 for x. In other words, I'm saying let's find the point on our line where x is 0, and then we'll calculate whatever y is. Well, if you think about whatever that point is, it doesn't even matter what y value you find. The fact that you made x equals 0 means I'm not moving to the left or to the right to graph this point. I am staying on the y-axis. So if I had the point 0, 2, then I would go 0 and then 2. That is your y-intercept. 0, 1 is your y-intercept. 0, 3.5 is your y-intercept. Right? So whatever point goes with x0 is your y-axis. I'm sorry, your y-intercept. Okay. And then the same thing, the point where the line, the x-intercept, is the point where the line crosses the x-axis. And that can be found by plugging in 0 for y. And then my question is, how come? Why? And the answer, again, is pretty obvious. If you are plugging in 0 for y, then you are letting the y equal 0, and you're solving now for what x value. And so if I have a point in the form of number comma 0, then that means I'm moving left or right and then not going up or down. So I'm not going up or down, meaning my point in question is going to be somewhere on the x-axis. I go over 3, like the point 30, the point 40, 50. They're all on the x-axis because their y values are 0. So if you want to find it, you just let y equal 0. And that is exactly what we did in our warm-up. We let x equal 0, and this found our y-intercept, right? That was this point right there. We let y equal 0, and that found our x-intercept. So it's not really anything to memorize. It's just something to be able to think about. Memorizing is great. If it's more learning, I guess, than memorizing, as long as you can piece your way through it. Okay, so why do we care? Well, because of what we just showed you in that warm-up. Graphing an equation that is in standard form. So again, remind you, standard form, the first definition, ax plus by equals c. You can easily find the intercepts when graphing when it's in standard form, saving us the trouble of putting it into slope-intercept form. So let's take a look at example number 1. Find the x and y intercepts and then use them to graph the function. All right, so to find the y-intercept, it's going to be a point, and it's going to be the point where we let x equal 0. In other words, plug in 0 for x. So the y-intercept is the point 0 comma something y. And if you just mathematically take a look at this, I'm plugging in 0, then this term becomes 0 and just disappears. And then I just have to divide by 3, and I get 4. That's it. Super simple. The x-intercept, this is going to be where we let y equal 0. And what's that going to do? When I let y equal 0, the term with y in it just disappears, and I get 2x equals 12, and I divide by 2, and I get 6. Now I can graph this point by simply graphing those 2 points. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4. 0, 4 goes up, 6, 0 goes over, and then I connect them with a line. Doesn't tell you the slope when you do it this way. You have to think about it a little bit to find the slope. So if that's important to you, you have to take a few extra steps. But if your goal is just to get a glimpse of this graph, this is a very simple way of doing it. All right, so example number 2, find the x and y intercepts, use them to graph. So I'm simply going to plug in x and get the point 0, comma. So x is 0. Visually, just kind of cover up the 5x in your head because that went to 0. And I divide, watch your negative, I get negative 5. Then I'm going to get the point, and I'm going to let y equal 0. So then that goes away. I divide by 5, and I get, what, negative 2? So I have the point 0, negative 5. That's my y-intercept. 1, 2, 3, 4, 5. And negative 2, 0. That's right there. And then I can graph them, and I'm done. Nice and simple. All right. So we're going to practice that today. In addition, we're also going to play with a little bit of writing the equation, being able to put it in standard form. So another skill in algebra is to be able to manipulate equations to look like other things. And we've done that before, putting them into slope-intercept. So here is an example of where we're in slope-intercept, and I would like you to be able to see if you can put it in standard form. So once again, standard form is just ax plus by equals c. We just use capital letters just to, I don't really know why, just to set them apart from the variable x and y. All right, and so a, b, and c are supposed to be integers, so no fractions. So what I could do to start, or I could do it at the last step, it doesn't really matter. I usually do it at the last step. But if I want to get rid of this 5 in the denominator, then I simply have to multiply everything by 5. But there's two parts, right? They have to be integers, and they also, x and y, you'll notice, are on the same side as each other. So really, I think probably the easiest first step is let's just simply add the 2/5 x to both sides to get it off the one side and move it to the other. And then I'll do it alphabetically, so x will go first. So I have 2/5 x plus y equals 1. So we've done most of the job, which is to get the x and the y on the same side. Now the other part is we want them to be integers. And so that means no fractions. So if I multiply the entire problem, all sides, by 5, then the 5 times 2/5 will cancel out, and I'm left with simply 2x. Nothing cancels when I multiply by the y, so I get 5y, and I multiply by 1, and I get 5. So this is the equation of the line in standard form. And again, the signs that you're in standard form is that integers and x and y are on the same side, and your constant is over on the other side. ax plus by equals the constant. All right, so let's go ahead and try this next one. And you'll notice I added this note. This is not like a you have to, but it is considered best form. So it's sort of like, it's kind of like, I guess, in English, like, you got pretty close, but you spelled the word wrong, or maybe your punctuation's off a little bit, but we get the gist. So what it says is the best practice is that your leading coefficient be positive. If you don't do it, I'm probably not. In fact, I won't take off on a test or something, but I'd like us to reach to a higher standard, which is best practice. So let's go ahead and follow what we did before. Let's move the 3/4 over. So now I get negative 3/4 x plus y equals 2. All right, we can't have a fraction, so I'm going to multiply the entire problem by 4, because that'll cancel out that 4, giving me negative 3x plus 4y equals 8. So that's good enough, but we can make it slightly better if now, or we could have fixed it by doing it in one step before. Let's now multiply it by a -1. Because by multiplying it by a -1, we're going to turn that leading negative into a positive. And again, as long as you do the same thing to both sides of the equation, then you're fine. So I'm going to multiply everything by -1, giving me the result of a positive 3x minus a 4y equals a -8. This would be considered the best answer. We could have done this in one step, if you notice, if we had just multiplied by a -4, because then that would have canceled out the 4 and taken care of the negative all at the same time. In case anybody is, confused or concerned, and you probably aren't, but if you wanted to now put this back into slope-intercept form, make it say y equals, it should still be the same equation. So let's go ahead and just try that real quick and see and show you that they are in fact still the same exact equation. I'm going to subtract the 3x and put it over here, giving me a -4y equals, I'll put my x's first, -3x minus 8. And now I would divide everything by -4, giving me y equals a positive 3/4 x, and a negative makes positive 2. And I scroll down, y equals 3/4 x, same exact thing. So all we did was we wrote it in a different form. Once again, the different form that you're in can have advantages in graphing and pulling information from the equation. And so this is another one that we can use. All right, hopefully that makes a lot of sense. And with practice, it should become pretty simple.